Alright, there we go again. This is the second part of the interpolation tutorial in which we got this far. Looks great? Looks great, but we cannot select anything from the list. So let's add the actual, selecting something from the list. Okay, so how do we do that? We wanna, in this render method, we wanna get some way to get the current interpolation. So right here we just say we take the bounce out interpolation, but this should be dynamic. So let's say get interpolation dot apply and stuff, but get interpolation doesn't exist. So let's go ahead and create it just on top right here. Private interpolation get interpolation. This is going to return the interpolation that is currently selected in the list. So now he's happy, but we want to return something different. We want to actually get the interpolation that's selected in the list. So we should probably add a listener to the list that sets some field to what's currently selected. For this, we'll just say private string selected interpolation. And then we'll let the list set this selected interpolation to, what's currently selected. So list.addListener, new change listener, that's what we need in this case. Because we want to check if the selection changed. So, there we go, change listener. Import that thing. Import again. And add the unimplemented methods, which is changed. So what do we want to do when it changed? We want to get, we get this actor parameter here, and we say actor dot, actually we don't even have to use the actor parameter, because we know that we add this change listener only to the list and nothing else. So we can say list, simple as that. List.get selection returns a string, and this is going to be selected interpolation equals list.get selection. Okay, pretty simple. But it's underlining this with the red stuff because list is not final. That's just Java stuff. You probably know that. Yes, I terminate this, and I don't like red font. Okay, so there we go. We select the interpolation by just saying if the selection in the list changes, get it and set this field to it. So this is just a string, it's not the actual interpolation yet, so that's what the get interpolation method is for. Okay, so how do we do that? We want to return an instance of interpolation. So we have to get the interpolation class and use a little bit of reflection. We want to get the field with the name of the selected interpolation, and then get the value, which is then wrapped into an object that we give this. We give this null because there is no object that we want this wrapped in. Okay, this is having a whole lot of errors. We just have to cast this to an interpolation because it doesn't know that the field that we select here actually returns an interpolation. And then we have to surround this with try and catch, because as you can see, all kinds of different crappy stuff may happen on the way. Okay. And then in case nothing, in case this try failed and any of these catches is, we just have to return some interpolation. So return null, for example. Or let's just say return interpolation dot linear. So that's the default interpolation, pretty default, yeah. Okay, so let's just have a look at this line again really quickly. We get the interpolation class, then get the field with the name of the selected interpolation, and then get its value. And as we can see in the Java doc here, it says, where is it? Oh, it's pretty long, isn't it? Here, parameters object. Object from which the represented field's value is to be extracted. What in the hell? Well, somewhere in here they say that this could, for example, be an interpolation. Well, not like this, interpolation. And if this would be an interpolation object, this value of the field would be put into this interpolation object. We could also use that, but we can also just give it null, so it puts it into the null, making the null something, and then returning this. Going here, and finally going here to our apply method again, and there we go. Let's see if I messed something up or if that's working already. I personally can't really believe it, and it isn't. Great. Let's see what is the problem here. He's having a problem here. Well, who would have guessed that? Now that's unfortunate. Get interpolation. Null pointer exception. Well, okay, that makes sense. So actually this method is fine, don't worry. But the selected interpolation in the beginning, well, it's nothing, it's null. So let's just say it's interpolation names 0. And that's it. So now we have one default selected for the start. And we have to start everything again. And there we go. Bounce, bounce in, bounce out, bounce in, circle out, all that stuff. We can now finally have a look at what's actually going on in there. Great. But as you probably remember, there was even more stuff. There was a time marker. There was this thing going from the top to the bottom. Let's see how far we get until it's in 5 minutes. Okay, let's get started. So for this time marker, actually what's more interesting, the time marker, that pretty comes together. So let's go ahead and create another float called time, which we initially set to 0. And then down here we have to draw the time marker. So let's at first increment time by the delta, which we get from here, the time passed since the last frame, and say if time is bigger than duration, set the time to 0 again. So what's duration? Nothing at the moment. Let's define it. Duration equals 2.5f. So that's just, well, the duration of the time marker that it takes for it to go from the left to the right side. Otherwise it's instant and then just is boring. Or it just went out of the graph, and that wouldn't make any sense at all. So now let's go ahead and actually draw this. Renderer.line again. Oops, wrong line one. Renderer.line. And this is again taking 2 points between which to draw the line. So we want to draw the line from bottom left x plus time divided by duration, because that's like step divided by steps. Okay, but actually graph size times time divided by duration, just like this. Graph size times percent. Percent was step divided by steps. And then on the y, because this is a time marker, it just goes straight down / straight up. So it's going to be bottom left. Oh, well, it's a y, so bottom left y. And then for the second point, bottom left x plus graph. So actually, let's extract this into a variable. Let's say time marker x, and all the stuff here is time marker x float time marker x equals all this stuff here, and bottom left y plus the whole graph size to go all up to, well, the graph bound on top. I hope that makes sense. Let's see if it works. Well, there we go. The time marker is going from left to right, and it's starting at the beginning again, because I said if it's over the duration, go back to time of 0. Like this, it's not really making any sense because it's marking time, but nothing is happening in that time. So we need to get this thing going on that was walking up from the top to the bottom there. For that, we want to use an actual a bunch of vector tools, because we want to draw a point at a position. So let's say we use a private vector2 start position equals new vector2 target position equals the new vector2 as well, vector2, and a temporary one, or let's just say position, the position that it's actually at right now, equals new vector2. Great. Now we need another method, because actually what we want to do is we want to say at first draw time marker, and then we want to draw position. So we have to use the renderer dot, for example, circle one, which takes position dot x, position dot y, and the radius of, I don't know, 7 or something. But position dot x and position dot y is at the moment 0, because, well, we didn't set it to anything else. We went up here and said position equals new vector2, so it's 0, 0 and never changes. But we actually want to set this to something else, because we want to say we want to update the position depending on the time that has passed. Here we go, update the position depending on the time, so that the time marker actually marks the correct position on the graph according to the position of the dot that we're going to draw. So let's go ahead and create this update position method right there. Private vector2 update position, or actually we could even say void, it doesn't matter at all. Update position, float time, and now we have to calculate that. Well, it looks more complicated than it is, okay, so don't get scared off. At first we want to set the position to the start position. Is that correct? Let me remember. Well, no, actually not. We want to set it to the target position, okay? Because let's say the position wants to go to the target position, so it's like, I'm at the target position, and then we have to say, no, you're actually not. So we have to subtract the start position. But now it's like, oh man, now I'm at the start position. And, well, it's actually not as well. We have to now scale by a scalar, which is the time that was passed in. Actually, not the time. It's time divided by duration. So it's a percent of how much time has passed, 100% of the time, 0%, 50% of the time. And by that, the position should be adjusted. So if it's 50% of the time, it should be 50% of start to target position, if you know what I mean. And then we can go ahead and add the start position again, because have a look at it like this. At first we have the target position, then we take the start position out of there, scale it, and add the start position again. Well, that was a great explanation, wasn't it? Not really. But I hope you can imagine what's going on. At first, let's save it and see if it's actually working or if I'm just talking crap. Because that might as well be the case. And, well, we don't see anything at all, because it's all happening in the bottom left corner there. Start position and target position is 0. So let's say we make another method called void reset positions, where we can just say start position dot set, let's say stage dot get width minus stage.getWidth divided by 5f, and stage.getHeight minus stage.getHeight divided by 5f. So it's like in the top right corner. Then the target position is going to be set to stage.getWidth minus stage.getWidth divided by 5f, so it's on the same x, and it's going to be stage.getHeight divided by 5f, right? Stage.getHeight divided by 5, yeah, so it's on the bottom, but not totally on the bottom. That's why I divide this by 5f. So that's what we do in reset positions. Let's just actually call this method. And actually let's call it once after we create the stage. Where is it? There. Reset positions. Because like this, we use the stage in this reset positions method. So we shouldn't better do it like this. We'll get a null pointer exception. We do it after creating the stage. And instead of just resetting time to 0, we want to reset the positions as well. So reset positions. And let's see what happens. What I forgot. And oh, this is already pretty fine, isn't it? He's going all the way down there, but he's not taking the interpolation into account. He's just doing like a linear interpolation of the time from target start to target position. So let's say he should take the interpolation into account. Okay, so how do we do that? We go to the get position method, update position method, and we have to do something with the actual position. We don't right now. We just scale it by time divided by duration, and have a look at down here in the render method. At first we just did times %, but then we said get interpolation dot apply the %, and that's actually the same thing that we have to do up here. This is like the %, and now we just have to say get interpolation dot right, dot apply this %, but this is a % of the time, so it'll get adjusted not to the linear %, but to the interpolation of this %. I hope my explanations make sense. You just have to figure that out in your head a little bit. And as you can see, it's totally working. It's bouncing all the way around. Let's say bounce out, and well, you can see it yourself. I guess this is working. Now, the other extra stuff was really just extras that you don't need. So they're just going to make it more complicated. Just one thing that we're going to do, we're going to say that we want to render the circle renderer.end there, and then renderer.begin shape type dot filled. Okay, so we have a filled circle. That just looks better. Okay, execute it once again, and there we go. It's working. I hope this made you understand how to use the interpolation class in LibGDX and how this example was built. Of course, there is more stuff to it. As we can see right here, interpolation test has you can edit the duration, and it's showing you the path, but that's really not complicated. That's just one more line renderer.line call, and this duration is just a little bit with a listener scroll listener. Really simple stuff actually. And oh well, you can choose the position, but well, this hasn't really got anything to do with the interpolation, so I don't think this should be in this tutorial. Alright, however, thanks for watching. I'll see you in the next tutorial, I hope, I guess. And until then, have fun developing, continue to be awesome, whatever. Alright, see you!